Hi students, today we are going to learn application of matrices and determinants where we are using to solve the system of linear equations, computer graphics, cryptography and etc. A cryptography means sending secret messages between two peoples or groups. In this chapter we have four methods, namely matrix inversion method, Cramer's rule, Gaussian elimination method, rank method. Before to handle these methods, we need to know some basic things. Let us know the basic things. Inverse of a non-singular square matrix. Non-singular, a square matrix A having its determinant value is not equal to 0 is called non-singular. If it is equal to 0, it is singular. What is inverse? Consider a real number x belongs to R where x not equal to 0. Then there exists y belongs to R. Then the product of x into y is equal to or y into x always equal to 1. It is possible when y defined as 1 by x. Then we can say y is the inverse of x or reciprocal of x. Thinking in the same way, let A be a square matrix and there exists B be a square matrix with the same order, then A into B and B into A are equal to I, unit matrix. Then we can say B is the inverse of A. Adjoint of a square matrix. Adjoint of a square matrix is nothing but a transpose of a cofactor matrix, and it is written as adj A is equal to Aij transpose. To find the adjoint of a square matrix involving a three-step procedure. Step 1 is finding minor and then cofactor and then adjoint. What is minor? Already we know all these things from 11th standard. Recalling once again, minor is the determinant of submatrix. Cofactor is the proper signed minor, and then the transpose of a cofactor matrix is called adjoint. For example, consider a 3 by 3 square matrix A having the element A11, A12, A13, A21, A22, A23, A31, A32, A33. Then we can find the submatrix of A for an element. Consider the element A11, then delete its row and column, we get submatrix of A. The determinant of submatrix is minor. So the determinant of submatrix A32, A23, A22 and A23 and A32 and A33. Then its value is the product of the leading diagonal. The product of the leading diagonal A22 and A33 minus the product of the subdiagonal A23 and A32. Then cofactor. Cofactor is nothing but a proper signed minor. We know that minor is denoted as Mij and cofactor is denoted as capital Aij and defined as minus 1 power I plus j into Mij. The proper signed minor is called a cofactor. Inverse formula. Consider a square matrix A, then its inverse formula is defined as A inverse is equal to 1 by determinant of A into adjoint A, and the properties of inverse. First one, determinant of A inverse is equal to 1 by determinant of E. Second one, A transpose of whole inverse is equal to A inverse of whole transpose. The third one is lambda A whole inverse is equal to 1 by lambda into A inverse, where lambda is a non-zero scalar. Students, and you have some more properties from theorem 1.5 to theorem 1.10. You have to read it and use it. Their proofs will be your live classes. Application of matrices to geometry. There is a special type of non-singular matrices which are using in computer graphics. In that, the transformation of one coordinate system into another coordinate system we can easily understand by the following diagram: two-dimensional analytical geometry. Consider the axis X,O,Y, and P be the point whose coordinates is x comma y. Then rotate the axis about an angle theta. Then the x-axis move on to here, capital X, and y-axis is here, capital Y. then the angle theta is here. Then the new position with respect to x and y is then we have theta is here, and draw perpendicular line to the small x and make this perpendicular touches with the x is n, and this one is L, and this point as Q, this point as T. Connecting Q and T, we have line here. Then the coordinates of P with respect to the rotating x, capital X and y is x is equal to OL from the diagram. Then OL can be written as ON minus LN. Then ON from the triangle OQN, we get ON is adjacent side. Then we have x cos theta minus LN is parallel to T and Q. Then from the triangle TPQ, we have sin theta as y sin theta. Similarly, y is PL, then it is in a two part, P to T and a T to L, PT plus TL. Then PT is parallel to QN, then we can write QN plus PT. From the triangle QON, we can write QN as x sin theta and PT as y sin theta, y cos theta, because PT is adjacent side of PTQ triangle, y cos theta. Then writing this equation in matrix form, we have x, y is equal to cos theta minus sin theta, sin theta and cos theta into capital X, Y. Then this matrix is considered as W. Then the determinant value of W is, determinant of W is equal to product of the leading diagonal elements, cos theta into cos theta, cos square theta, minus sin theta into minus sin theta, minus sin square theta, then minus into minus will be plus sin square theta. Then by the trigonometry identity, it is equal to 1. Then adjoint of W is cos theta, sin theta, minus sin theta and cos theta. Then the inverse of the W is W inverse is equal to 1 by determinant of W into adjoint of W. Then we get cos theta into in sin theta minus sin theta cos theta. Here we can observe that W transpose is also equal to W inverse. That is, W inverse is equal to W transpose. Then we get the inverse transformation by the equation as x y into W inverse as capital X y. This transformation used in computer graphics and denoted by the matrix W, and W satisfies the special property that W inverse is equal to W transpose. Then we have W and W transpose is equal to W transpose into W is equal to I. This one is known as orthogonal property. Application of matrices to cryptography. One of the important application of inverse of a non-singular square matrix is in cryptography. Cryptography is used to communicate between two peoples by keeping the information is not known to others. It is based upon two factors, namely encryption and decryption. Encryption is the process of making a readable message into unreadable, and decryption is the process of unreadable message into readable message. Come, let's send the message and receive the message. My message is come, and I assign the numerical value for the alphabets, and I break my message into two parts, CO and ME, and I assign the value of CO and ME and make it as a row matrix. Then I take A as a square matrix containing the elements 1, 2 and 0, 1. It's a simple matrix. Then we are going to encode the message. First one, we have uncoded row matrix, and this is encoding matrix. And we have coded message here. It's a coded matrix. The first one 3, 15, and the encoding message is 1, 2, 0, 1. Then we multiplying, we get 3 plus 0 and 6 plus 15. 3, 21. The coded message is 3, 21. The second row matrix is 13 5 with the encode matrix 1 2 and 0 1. Multiplying we get 13 0 and 26 plus 5. Then our coded message matrix will be 13 and 31. Therefore, the encoded message is 321 and 1331. Then we are going to decode the message now. For that, we need to find the A inverse. A determinant of A is equal to 1 minus 0 is equal to 1. And the adjoint of A is equal to 1 minus 2 0 and 1. Then the A inverse is equal to 1 minus 2 0 1. For the similar process, first we have coded row matrix here and a decoding. The inverse matrix is here. Then we get the decoded row matrix. So continuing the similar process, we get the decoded matrix here. So the decoded matrix, again with the help of the numerical value, transform into the original message as